Good afternoon. This afternoon we're going to talk about how to create a cut list and optimized layouts for table saw cutting of our cabinets. In the last segment we left off with finishing our model, and I described to you how you can create shop drawings in SketchUp. If you are a professional and you have SketchUp Pro, it comes with layout, a professional presentation and drawing package. It's a 2D drawing package, but it's ideally suited for drawing shop drawings. And what I want to do here is to show you this particular model, which was designed by Greg Larson, the owner and operator of New England School of Architectural Woodworking. This was for a customer who's an artist and had strong ideas about a kitchen design. Greg designed this in CabWriter and manufactured or produced this kitchen, and you can see finished pictures of it on our website, CabWriterSoftware.com. All one word, no spacing. CabWriterSoftware.com. But I wanted to show you some of the shop drawings he created for this particular model and just give you a quick tour of the model. You can see there's some different types of cabinets here. A lot of cabinets with open spaces here. Some cabinets with tray-like drawers. And different depth cabinets here for the island. Well, not the peninsula. So okay, let's look at some of those shop drawings. I think you'll agree that those drawings look pretty professional. And what's really nice is if you make a change to SketchUp, you can easily update the layout drawing because it synchronizes with SketchUp. And so this continues the philosophy of having all of your drawings in one database. That is the SketchUp database. Okay, now what I want to get on to what we really want to do today, which is create cut list for the table saw cutting. I want to demonstrate to you something that you need to be aware of. Every time you modify a cabinet using the edit command, you renumber the cabinet. And I'll show you that by bringing up the extended entity info. And I'll choose this cabinet right here. Notice it's numbered cabinet C3. I'm going to edit that cabinet. And I'm actually going to change it a little bit. I'm not going to change the styles, but I am going to change the cabinet itself from a standard base with drawers to a blind corner cabinet. And I'm going to continue to have one door, and I'm going to have one drawer. Let me say OK. And notice what I did. From the front, the cabinet still looks the same. One door, one drawer. But back here, we have extra space for storing things. If we open this door, we can store things all the way back to here. But now let's choose this cabinet and let's look at what the cabinet number is. It's C19. Okay, so what we want to do is we want our cabinets to have contiguous numbers. So the first thing we want to do before we produce a cut list is to renumber all the cabinets. We can do that right here with this icon. Renumber cabinets. And now watch if I choose this cabinet. It's cabinet 1. That's cabinet 2, cabinet 8. I'm not sure where 3 is, and it really doesn't matter as long as our cabinets are contiguous. Okay, so now we've renumbered the cabinets. The next thing we want to do, well, probably the next thing we want to do is save this file. We want to create a cut list. Oh, one more step that I want to mention. One of the columns that we will find in the cut list is tags. The tag column. The tag column is meant for the user of SketchUp and Cutlist Plus FX to put something in there that indicates perhaps a shop process. One shop process is grain matching. For instance, if we were to zoom in on this, notice we have this miter cut here. We probably want to match this grain. So we might want to make a note to ourselves to do that. So we'll probably select both of these styles, the one on the end and the one in the front, and put a tag in here called Grain Match 1. Okay, we finally got Grain Match 1 in there. And if we come back to either one of them, we'll notice Grain Match 1 is in the tag field. Same with this one, Grain Match 1. I'm not going to do this, but you should do it to all of the styles that come together like this. For instance, this one and this one might be called Grain Match 2. And this one, and this one, Grain Match 3. Okay, once you've done things like that, once you've filled in the tag field, you might also want to fill in notes for any one of the components you want. And I'll just fill in one here. Oh, we'll just pick one. And then I'll just put something here that may not make a lot of sense, but I'll just say this is a blind cabinet. And leave it at that. This is a blind cabinet. Okay. Again, the last thing I want to do here probably is save this now that I have tags and notes and what have you in here. And now it's time to make a cut list. Remember way back when I first started doing this drawing, I said we ought to have a special scene called Cut List Export for making a cut list. And we have one. So let's choose that. And what it's got in it, I can close this now. What it's got in it is all of the cabinet parts that were drawn by CabWriter or were CabWriter parts that were modified. And I'm ready to produce a cut list. So let's choose File, Cut List Bridge, and I have my choice: Export to Cut List Plus FX or Export to Microsoft Excel or OpenOffice. I'm going to do both. I'm going to say Export to Cut List Plus FX, and I get a warning sign that says I can't export because nothing's been selected. So what we have to do before we create a cut list is we have to select all of the components that we want on the cut list. An easy way to do that is to select all. Now I can go to Cut List Bridge and say Export to Cut List Plus FX. And it says a cut list file has been written to, and it tells me where it's been written to, and the name of it is CabWriter Segment 5 Training CWX. Okay, the first thing you want to notice is that the folder that it will put this file in is the same folder as the model. So wherever the model exists, that's where it's going to place the file. Same folder. The other thing is it uses the same model name as the file, the skip file, and you can see that up here, CabWriter Segment 5 Training Skip. And notice that down here it's CabWriter Segment 5 Training, but instead of skip, it's .cwx. So at least I'll know where that file is. And by the way, while I'm at it, before we look at that file, I'm also going to export to Microsoft Excel or OpenOffice. This is going to produce a CSV file instead of a CWX file. And again, it'll put it in the same folder as the model, but instead of a CWX, it'll be a .csv. These files are slightly different. But let's look at the CWX first. The CWX is interesting because it produces a file that if you have Cut List Plus FX, you can automatically associate the .cwx file with Cut List Plus FX. And all you need to do at that point is simply click on the file in the folder where it's stored, which I will do right now. It'll open Cut List Plus FX, and you will be able to see the cut list immediately in front of you. All right, so now let's look at this cut list. First thing I want to point out is, do you remember we put a note on one of the components? Well, you'll notice there's no notes up here. Where are the notes? Well, if you see this little red tag here, that says that component has a note attached to it. And if I hover over it, it'll tell me what the note is. And the note is, this is a blind cabinet. So that's where your notes will show up. Remember, we had some shop process things here. Grain matching. So if I get down and look, I'll notice some of my parts have notes that say this should be grain matched, this component should be grain matched number 3. So there should be a corresponding grain match 3. Well, I can sort by tags. And notice there are 2 grain match 3s. So those 2 components need to be grain matched. These 2 components need to be grain matched. And these 2 need to be grain matched. And of course, there would have been a lot more had I completed the model with all the grain matching. If you have other shop processes that you have to perform once things are cut out, you can create your own. There was nothing unique about GM1. I just made that up as grain match 1. You might have other shop processes that you want to put in this column. Now, I want to just show you what the columns are here. This is the part number. When we reordered the parts, this is what was produced, part numbers that were in consecutive order. You'll notice if I sort by this, it starts off with 1 and then numbering happens to go to 10, 11, 12, 13, 14, 15, 16, up through 19. And then it goes to 2, 20, 21, 22. I'm sorry, I'm looking at the wrong thing. This is C1, Cabinet 1. This is Cabinet 1, Part 1, Cabinet 1, Part 10, Cabinet 1, Part 11. But the thing about cabinet numbering and the parts of cabinets is that it starts off with C1 and then goes to C10. And then it'll go to C11. Down to C14. And then it'll start with cabinet 2 and go on up through cabinet 9. So we have 1 through 9, and our highest cabinet is 14. They're all in consecutive order, no integers missing in the cabinet order. There we go, C14. And so we can sort by the cabinet number. Probably the most interesting thing to do is to come down the list here and start off by sorting by material name, material type, description, subassembly, and part number. I find that to be the most convenient way to look at this, but you can sort your columns any way you want. Now, let me just describe what some of these are. This is subassembly. Our subassembly is really the name of the layer in this particular cut list, the layer that it's on. If I go back to the model, remember that I had things organized by base boxes, base doors, base drawers, base end panels, base face frames, base ladder, and then the uppers as well. Well, in my output here, what I did was I said, choose for a subassembly name the layer the component is on. And that's what I got. So for the subassembly, I got the layer the component's on. In other words, all the upper boxes, if I sorted by this, I can build the end panels first, then the face frames, and then the ladder, upper box, upper doors, so on and so forth. Now there's another way you can name subassembly. And I'll show you that, although I don't propose you do it for this particular type of modeling, which is cabinets. If it were furniture or something else, I would definitely propose it, but I'll show you in a moment. All right, now the description of the part is actually the component name. So if you look at each component, you'll see it starts off with the cabinet number, whether or not it's an upper or lower, and the type of part. This is door 1. This is C13, cabinet 13, upper end panel, right end top rail for the end panel. the number of copies of each you need. This is the cutting thickness, the cutting width, and the cutting length. And so if some of your parts were oversized, these numbers will be different than the finished dimension. How do you tell the finished dimension? You look in this column over here. This is the finished thickness, finished width, finished length. Now you can look down this info column and you'll see a TWL or TW or WL or sometimes nothing. And what this is a quick indication of what things have been resized and in what dimensions. This one has been resized in thickness and in width and in length. This one's only been resized in thickness and width. This one's been resized in width and length. And some have not been resized. Well, these were only resized in thickness. I don't know if I'll find one that's not been resized at all. Yeah, here's some that have not been resized at all. And so this is a quick indication of what things have to be tended to for final dimensions. This column is banding. If you have shelves, for instance, where you're going to put banding on the front of the shelf to hide the plywood finish, this is where you would indicate the banding. Now, I haven't used any here in this particular model, but it would show up here if you're going to use banding. There are some parts that can be rotated. And let's see if I can find one. Okay. This is a stretcher. Stretchers are not seen by the customer. And so if you're using sheet goods to make a stretcher, you don't care which direction the grain runs, whether it runs the length of the stretcher or the width of the stretcher. But what it does do is it allows the optimization tool to save you plywood if you indicate it as something that can be rotated. So these are parts that can be rotated because you don't care which direction the grain is showing. And that will optimize the amount of plywood that you need. This is the material name, or I should say the material, well, yes, the material name, or perhaps the species of the wood. This is the type of material: sheet good, rough lumber, and dimension lumber if you had it. And so this is the typical column that you will see if you use Cutlass plus FX. Well, let's go across here and look at some of these tabs. This indicates other items. Other items are like draw pulls and things like this. We don't have them in this cutting diagram. We could if we wanted to, but I didn't include them in this cut list output. This is the labor. I don't have any indicated here, but I could input labor for each of these components. This is the bill of materials. I don't have things like, well, I don't have the exact cost for sheet goods and things like that in here. But if you went to the raw materials tab, you could enter for, let's say, 3/4 inch plywood, maple plywood pre-finished. You could enter for 3/4 inch maple plywood the dimensions and what it cost on a sheet basis, and whether or not you have some in inventory and what have you. I haven't done that, so at the moment pricing won't be accurate. But you have that capability for almost all of these things: labor, materials, other items. You can do that with Cutlass plus FX. Probably the most interesting thing with Cutlass plus FX is the layouts. What Cutlass Plus FX will do is for every sheet good and hardwood, if you actually set it up to do it, it will optimize cutting lists. Let's choose maple plywood, pre-finished 3/4. Notice over here in this right column I have a bunch of diagrams. And they're numbered 1 through, in this case, 12. And I can look at each one of them. That's number 12. And notice it's got an optimized cutting diagram for how you would cut this on the table saw. Further, if you had to have more than one sheet with this same cutting, it would indicate that down here. Quantity of this diagram. Well, there's only one in this case. I don't know that there's ever going to be one with a 2 here. Let me just take a quick look. No, in this case there probably isn't, but in furniture pieces you will often find a cutting diagram that requires 2 sheets of the same cutting diagram. That's not the case here. But if you did, that would be indicated down here. But each one of these highly optimizes the use of the plywood so there's no waste. And that's reflected in your pricing. You will see that in your pricing. If you have partial sheets in stock, you can tell Cutlass Plus FX the size of those sheets, how many you have, and it will also use those up. So it does a really good job of optimizing sheet good material. So that's the 3/4 inch plywood. If I had maple plywood 1/4, which I do, it'll have cutting diagrams for those. So these you actually can take into the shop and it tells you how to cut these out. There's a number of things you can do to optimize how this is done. I'm not going to go through that right now because this is not a course on using Cutlass Plus FX, but you will find Cutlass Plus FX to be very useful. So let me go back to my parts list again. And remember over here I told you that you could change how this is. You have some options for subassembly. Let me go back to my SketchUp drawing and look at the extended entity info setup page. Now the way I had this set up for this cut list was I said the component numbering was going to be done by CabWriter. And remember, we renumbered all of our components. So CabWriter provided the component numbering. And since CabWriter's supplying the component numbering, we don't care whether we've checked numerically or alphanumerically. CabWriter will determine what the numbers are. Whenever using CabWriter, I use this W only. And that is because I don't want to clutter things up. Notice here I had just letters, W, WL, TW, TWL. Well, it's possible if I wanted to know how much something was oversized in width, if something was oversized 1/4 of an inch, I might want to indicate that here. Or I might even want to indicate the final dimension here. I can do that by choosing one of these other 2 indicators. But it really gets sloppy, and since I have finished dimensions columns anyway, I really don't need it. So I just choose W. I also use this left side choice here instead of left side and in brackets the type. For instance, if I chose this and I were printing out the component side, it would tell me it's a side component. If I were printing out a back, it would tell me it's a back component. But that's superfluous information. You really don't need it. I choose the left side. Here's the one I wanted to get at. Notice I've chosen model layer for subassembly. If I take a look at a component here, any component, this subassembly is called C13UB2. It's basically the prefix of the part. I could put anything I want in here. I could call this anything I wanted to in this subassembly. And if I did, then I could print out, I could choose this radio button, and I could print out that information in the subassembly column. That's very useful if I'm designing furniture. So this is the setup I recommend for CabWriter right here. All right, now I want to go back and look at the CSV file that we printed out. I can open it in one of two ways. I can open it with OpenOffice, or I can open it with Excel. I'm going to do both. I'm going to first open it with OpenOffice. And since I've set this up and mapped all the columns once before, I don't have to do it again. I'll just say OK. And here is my OpenOffice cut list. Now the OpenOffice cut list works a little differently. Here's all rough lumber. This is all the rough lumber. This is all the sheet goods. Same component numbers. And again, the subassembly is basically the layer that things are on. Same description, same number of copies. Thickness, width, and length is the cut thickness, width, and length. Again, here's the finish over here. Finished width and length. Right there. There's the tags. Notes this time actually appears in the notes column. And can rotate appears a little bit differently, but if you sort by this column, you will see there are some things that can be rotated. So this is the OpenOffice style of printout. And if I go to Excel, it'll look very similar. I'll do that right now. All I have to do is say open this CSV file. Instead of with OpenOffice, I'll open it with Excel. And you'll see this is very similar. In Excel, of course, you have to do things like open up these things so you can see everything. But it's got the same layout. Rough lumber, sheet good, and all the same columns. So getting a cut list is very easy. And if you don't want to spend the money for cut list plus FX, you can use OpenOffice or Excel. I want to mention one other really nice feature of Cut List Plus FX. One of the things you can do is print out, not going to do it here, but you can print labels. Not actually going to do it, but the nice thing is about this, you can print them on label stock, and as you are cutting parts you can place the label on the part, so you'll know what cabinet number it belongs to and what part number it is. And it's got a lot of other information on it as well. Okay, so that's pretty much it for cut lists. I'm going to save my model. And in the next segment, we're going to show you how to create optimized drawings and how to create the DXF files for cutting things on CNC machines. So until then, have a good day.